So coordinate systems, of course, describe 3D spaces, and we have a few 3D spaces that we can consider. Something that's called local object is simply the coordinate system where the original object was designed. So this is just basic geometry. Then the world, of course, is how objects are placed in the world. View and camera is the coordinate system relative to the camera or to the eye of the observer. So to demonstrate the view, right now our view is located directly in front of the screen. But of course, once again, I could move the observer to a different position. So they will be looking at this cube from this position. And the coordinate system here, XYZ coordinate system of the observer or view camera coordinate system, will look like this. Right, so this will be a different positioning right here of the coordinate system. And so that's the coordinate system relative to the camera or observer. We also have clipping involved in 3D graphics because depending on the position of the observer or camera, the entire world may not fit into our actual view. So for example, if I try to resize this window, you see what happens is that part of this cube just simply begins to disappear. So we're saying that parts here have to be clipped. So that's obviously related to the windowing system, our actual view that we're using to display our current world. And in general, of course, we have to transform from the original geometry to position our objects somewhere in our world. Then we have to position the viewer who will be seeing this, and then finally the windowing system supposed to make it fit somehow and make it visible in the current view that we configured. And of course we use the mathematics to do all the transformation of vertices in this progression of transformations from one coordinate system to another. So the entire term OpenGL stands for Open Source Graphics Language. But it's actually not a programming language. So it's just an application programming interface. We have a library that we have on our system that allows us to make calls from our CPU to the graphics hardware. So basically, if this side of my screen, the left-hand side of my screen, represents the memory and CPU executing program in our memory, then this part of the screen may represent the graphics hardware. And basically what this API allows us to do is that when we have a program executing in the CPU, right here, this API allows us to communicate from our program running in the CPU to the graphics hardware, which eventually will render this on our screen. Also, it comes with a shading language. And the shading language is a C-like language, which is very easy to understand if you've seen the syntax of C. And it actually is the language that we need to use to write code that executes in graphics hardware and makes this rendering visible. So a little bit of history of OpenGL. Originated somewhere in 1992. But really the original version of it was fixed function pipeline, which means that the graphics card was not programmable. All the geometry transformations, color assignments, all work had to be done in the CPU memory, and was the function of the actual CPU, so only rendering was done in the graphics. So you could not change or alter the behavior inside the graphics card. And right now, starting with version 3.3 is more or less the standard of OpenGL API, and the shading language that we use that allows the basically is the new standard is that the graphics hardware is now programmable, so the programs can also run in the graphics card. The approach and philosophy of OpenGL that it is a state machine that uses a client-server model. Basically, this is like a closed box where it remembers its state. So until we do something, it just stays like it is. But if I start changing something, so if I want to do my rotations here, then we essentially send commands, and these commands, you can see that the result is that we see a change, but until we do something like that, it just stays the way it is. It's called state machine, and that state machine involves everything, basically our viewing space, this background, the actual rendering of the world, and everything that you can see. And our C or C++ program is the client. Okay, and of course the GPU driver and the GPU hardware is the server. So the client sends commands to the server, and glue is the library that we use that connects, basically connects the CPU and GPU, and asks the driver to provide us access directly to the hardware, and it is used only initially, and it assigns the actual physical addresses to functions that are available inside the graphics. So we can now start using our client C or C++ program that communicates with the hardware. Of course, C and C++ is only approach that I'm taking in this series of labs in our course, but you can also write your OpenGL programs in Java, in other programming languages. So we are using a number of helper libraries that will be part of our laboratory project configurations. So we have this OpenGL 32.lib that we're using. We have the utility toolkit that supports the actual windowing. It's isolating us from a specific operating system interface to interact with actual windows that can be minimized, maximized, resized, closed and opened. Glue is the extension wrangler for determining which vendor extensions are available and loading them into our memory space. So basically the glue is the library that is needed only once when the OpenGL program, the client program, starts executing. It makes a couple of calls into this library, and that library establishes our connection between the CPU program and the hardware that is available on our system. OpenGL mathematics is just general purpose OpenGL mathematics set of mathematical functions for vector and matrix math, and it's a wonderful third-party library that also open source library that we use with OpenGL, that we can do a lot of things necessary to be able to do our transformations in 3D space and formulate those matrices that explain how we want to position and change the shapes of our objects. There are some other libraries that can be used that basically replace these libraries. So it's a complex world, and we have a lot of different options to configure our OpenGL projects on different platforms and be able to run OpenGL programs.